So y is equal to sin square x cos cube x. Y is equal to sin square x cos cube x. Now here you know this standard formula nth derivatives of sin and cos functions. So you want to convert this function to sin and cos. So same thinking as an integration. In integration also our same thinking. What is the formula? What would for that particular function in the integration? So you want to convert that function to the standard formula. Then you want to integrate. Here also, what is the standard formula for nth derivatives? You want to convert. So you want to convert this function in pure sin and cos functions. So by using the trigonometric formula, you will. Now sin square. So you know this 1 minus cos x formula to sin square x. So sin square x is 1 minus cos x upon 2. So 1 minus cos x upon 2. Now cos cube x. So you will recall the formula cos 3x. So cos 3x is equal to 4 cos cube x minus 3 cos x. So from this cos 3x plus 3 cos x, and this 4 will get here divided. So that is the cos cube x value. So that value will introduce here. So cos 3x plus 3 cos x divided by 4. So that is equal to 2 into 4 is 8, 1 upon 8 into bracket. Now we multiply 1 to this function. So cos 3x plus 3 cos x minus cos x into cos 3x and minus 3 into cos is a cos square x. Now you know this here 1 plus cos x, here x by 2, 1 minus cos x, 2 sin square x by 2. So here angle is 2x. Cos 2x is 2 sin square x. Cos 2x. So 1 minus cos 2x is 2 sin square x. Like this. So sin square x is 1 minus cos 2x upon 2. This is our theta. So here cos 3x plus 3 cos x, cos 2x, and cos, here we get cos 2x into cos x, cos 2x and cos x. So here the product you want to consider in addition. So that will y is equal to write 1 upon 8 into bracket. So cos 3x, this is in the standard form, plus 3 cos x minus. Now here you want to multiply 2 and divide by 2. So 1 upon 2 cos. Now this is in the standard formula. This is standard formula. So here this product you want to convert in addition. So we'll use the formula 2 cos A cos B is equal to, you know the formula, cos A plus B plus cos A minus B. So by this formula we will get 1 upon 8, y is equal to 1 upon 8 into bracket cos 3x plus 3 cos x minus 1 upon 2. So cos 3 plus 2 5x plus cos minus x minus 3 upon 2 cos 3x plus cos x. So that is equal to 1 upon 8 into bracket cos 3x plus 3 cos x minus 1 upon 2 cos 5x. Cos of minus theta is cos theta. So minus 1 upon 2 cos x minus 3 upon 2 cos 3x minus 3 upon 2 cos x. So that is y is equal to, we get 1 upon 8 into bracket. Now we combine the terms. So cos 3x, cos x terms 3 cos x minus 1 upon 2 cos x minus 3 upon 2. So minus 3 minus 1 minus 4 upon 2 minus 2. So minus 2 and plus 3. So cos x. Cos 3x minus 3 upon 2 cos 3x. So 1 minus 3 upon 2. So minus 1 half cos 3x and minus 1 upon 2 cos 5x. So since if y is equal to cos ax plus b, yn is equal to a raised to n cos ax plus b plus n pi by 2. So this formula is applicable here. So yn is equal to 1 upon 8 into bracket. Here a is equal to 1. 1 raised to n is 1. So cos x plus n pi by 2 minus 1 upon constant 3 raised to n cos 3x plus n pi by 2 minus 1 upon constant 5 raised to n 5x plus n pi by 2. So this is the nth derivative. Now see this nth example. Let y is equal to e raised to x cos 2x cos x. So here you want to convert this cos 2x cos x into pure cos. So 1 upon 2 cos 2x and cos x. So 1 upon 2 e raised to x cos 3x plus cos x. So 1 upon 2 constant e raised to x cos 3x plus e raised to x cos x. Now this is in the standard form. We write the formula. Since if y is equal to e raised to x cos bx plus c, yn is equal to r raised to n e raised to ax cos bx plus c plus n pi, where r is equal to under root a square plus b square, phi is equal to tan inverse b by a. Now here for this first example, a is equal to for e raised to x cos 3x, a is equal to 1, b is equal to 3, c is equal to here 0. So r is equal to under root 1 square plus 3 square. So root 10 or 10 raised to half. Phi is equal to tan inverse b upon a, that is tan inverse 3 upon 1. So tan inverse 3. Tan inverse 3. For e raised to x cos x. So a is equal to 1, b is equal to 1, c is equal to 0. So r is equal to, we get under root 1 square plus 1 square. So root 2 or 2 raised to half. And phi is equal to, we get tan inverse 1 upon 1. So tan inverse 1, and that is we get as a pi by 4. Therefore yn is equal to, now you put this value in the formula. So 1 half constant into bracket. Now e raised to, for this function e raised to x cos 3x, r is equal to 10. So 10 raised to n by 2. 10 raised to half means 10 raised to n by 2. E raised to x cos 3x plus n 3x plus n pi n into tan inverse 3. plus, now for this function r is equal to 2 raised to half, so 2 raised to n by 2 e raised to x and cos x plus n pi by 4. So e raised to x we can take outside, so 1 upon 2 e raised to x into bracket 10 raised to n by 2 cos 3x plus n tan inverse 3 plus 2 raised to n by 2 cos x plus n pi by 4 . Now we will find the derivatives of y is equal to tan inverse x function. So tan inverse, for tan inverse x, no standard formula for nth derivatives. So if we take the derivatives of this tan inverse, you know this 1 upon 1 plus x square. So first of all we take the derivatives of this y. So derivatives of y is y1. y1 is equal to, we get 1 upon 1 plus x square. That is 1 upon x square plus 1. Now we can factorize this. We get the factors as imaginary factors that we have stated in the introduction of the algebraic function. So y1 is equal to 1 upon x minus sin x plus I. Now we will do the partial fraction. These are the linear factors not repeated. So 1 upon x minus sin into x plus I is equal to a upon x minus I and plus b upon x plus I. So that 1 is equal to, we get a into x plus I plus b into x minus I after taking LCM. Now to find value of a, x plus I minus I is equal to, we put 0, so x is equal to I. So E1 is equal to, we get a into I plus I is 2I, this is 0. So a is equal to, we are getting 1 upon 2I, that is minus I by 2. Now to find value of b, we put x plus I is equal to 0, that is x is equal to minus I. So 1 is equal to, we get, this is 0, so b minus I minus 2I. So b is equal to minus 1 upon 2I, that is we get I by 2. So y1 is equal to, we get, now I by 2 will take common outside, so minus 1 upon x minus I plus 1 upon x plus I. So y1 is equal to I by 2 into bracket, positive term will write first, so 1 upon x plus I minus 1 upon x minus I. Now you know this formula, if y is equal to 1 upon x plus b, and the derivative formula y is equal to minus 1 raised to n factorial a raised to n divided by x plus b raised to n plus 1. Now here comparatively a is equal to 1, b is equal to maybe plus or minus 1. So y n plus 1, derivatives of n, the derivatives of y is yn. y1 is yn plus 1. So y plus 1 is equal to, we get I by 2 into bracket minus 1 raised to n factorial divided by x plus I raised to n plus 1 minus 1 raised to n factorial x minus I raised to n plus 1. So minus 1 raised to n and n factorial will take common outside. So I into minus 1 raised to n factorial upon 2 into bracket 1 upon x plus I raised to n plus 1 and minus 1 upon 1 upon x minus I raised to n plus 1. So this is yn plus 1. Our requirement, we want to find yn, that is the derivative of tan inverse. So yn is equal to, we get I minus 1 raised to n minus 1 factor. We are putting n is equal to n minus 1 upon 2 and 1 upon x plus I raised to n minus 1 upon x minus I raised to n. Now to convert this result to the polar form, so we can simplify further. So I minus 1 raised to n minus 1 factorial upon 2 x plus I raised to minus n and minus x minus I raised to minus n. Now here z is equal to, suppose x plus I, then modulus r is equal to under root a square plus b square means 1 square plus 1 square, so root 2, that is 2 raised to half, and theta is argument, amplitude theta is equal to tan inverse 1 upon 1, that is for tan inverse 1 is pi by 4. Now if we put these values here in this result, so I into y, this yn is equal to, we are getting I into minus 1 raised to n minus 1 factorial upon 2 into root 2 raised to minus n cos pi by 4 plus I sin pi by 4 raised to minus n minus root 2 raised to minus n cos pi by 4 minus I sin pi by 4 raised to minus n. Now root 2 means 2 raised to half, so 2 raised to minus n by 2 will take outside into bracket, so cos we cos pi by 4 plus I sin pi by 4 raised to minus n minus into bracket cos of minus pi by 4 plus I sin minus pi by 4 raised to minus n. Now this function in the polar form, so we can use d inverse theorem. So by d inverse theorem, yn equal to I minus 1 raised to n minus 1 factorial divided by 2 raised to minus n by 2 into bracket. So you know this cos of minus n pi by 4 plus I sin minus n pi by 4. So when the function in the polar form, power is multiplied, that is the de Moivre's theorem, minus into bracket cos of minus plus n pi by 4 plus I sin minus plus n pi by 4. So that is equal to yn is equal to, we get I minus 1 raised to n minus 1 factorial 2 raised to minus n by 2 divided by 2. Cos of minus theta is cos theta, so cos n pi by 4, sin of minus is minus I sin n pi by 4 minus cos n pi by 4 plus I sin n pi by 4. Minus this here, minus we are getting. Now cos n pi by 4 plus minus gets cancelled. At the minus I sin by 4 minus, that is minus 2i. So I into I, so minus 2i square minus 1 raised to n minus 1 factorial 2 raised to minus n by 2 minus 1 and sin n pi by 4. I square is minus 1, so minus plus, so 2 minus 1 raised to n minus 1 factorial sin n pi by 4 divided by 2 raised to n upon 2 plus 1. Or this 1 and this 2 we can cancel, this 2 raised to n half. So this is the nth derivatives of tan inverse x. 10th example. So y is equal to function x square e raised to 2x. Now you want to find here nth derivatives. So here the product of the function u and v. So while selecting u and v, so u is the first function, so you choose u whose we are getting the nth derivatives, and always you select the v function whose derivatives are stopped. That is algebraic function, power function, you always take v. So we will take this v and this u function. So u is equal to e raised to 2x. So you know this un is equal to, we get 2 raised to n e raised to 2x. So you know this standard formula, if y is equal to x, e raised to x plus b, yn is equal to a raised to n e raised to ax plus b, that by that formula. And so let u is equal to, let p is equal to x square. So v1 is equal to let to x, v2 is equal to 2, v3 equal to v4 is equal to V3 is equal to 0, constant derivative 0, that is equal to again V4 and so on up to Vn. So all the derivatives, higher order derivatives are 0. Now here we'll use Leibniz theorem. So by Leibniz rule, so you know this Yn is equal to UVL, and that is equal to Un plus n into Un minus 1 V1 plus n minus 1 upon 2 factorial Un minus 2 V2 and so on, dash. Last we get Vn. So Yn is equal to Un is 2 raised to n e raised to 2x plus UnV plus n into n minus 1. So V is equal to x square, so into x square plus n. Now Un minus 1, so instead of here n, we'll put n minus 1. So 2 raised to n minus 1 e raised to 2x into V1 is 2x plus n minus 1 upon 2 factorial Un minus 2. So 2 raised to n minus 2 e raised to 2x into V2 is 2. Now higher derivative 0, so that is zeros. So Yn is equal to, we are getting 2 raised to n e raised to 2x into x square plus n 2 raised to n minus 1 and into 2 means 2 raised to n x e raised to 2x plus 2 factor 2, this gets cancelled, so 2 n into n minus 1, 2 raised to n minus 2 and e raised to 2x. Now here at x is equal to 0, if you put x equal to 0 here, Yn equal to, so this is the 0, x is here, so 0 plus n minus 1, 2 raised to n minus 2 e raised to 0, 2 into 0, e raised to 0 is 1, so n minus 1, 2 raised to n minus 2, so that is equal to, Yn is equal to 2 raised to n minus 2 into n minus 1, that is the result, hence 2. So 11th example. So we have cos inverse y upon b is equal to log x upon n raised to n. So y upon b is equal to, we get cos inverse, if you take the cos into bracket n into bracket log x minus log n, log a upon b, log a raised to m, that formula we are using. So y is equal to simplified function b into cos n log x minus log n. So in when we find the nth derivative, always you obtain the function y is equal to simplified function, and then now here you want to find yn plus 2, and you know this nth derivative of y2 is yn plus 2. So first of all you want to find here y2 by higher order, second order derivative method. So y1 is equal to, we get b constant, derivative of course is minus, so minus sin n into bracket log x minus log n into derivative of this n, so n constant, log x is 1 minus 0. So y1 is equal to, we are getting minus bn, this minus n b sin into bracket n log x minus log n Now differentiate this again with respect to x. No substitution we are getting. So derivative of y1 is y2. Sorry. We have not taken the derivatives of log. Y1 is equal to minus b sine, derivatives of cos is sine, n into bracket log x minus log a into derivatives of n, log x is 1 upon x minus log n is 0 1 upon x. Now we are not using u by v, so x will take on this side. So x y1 is equal to minus nb sin n into bracket log x minus log n. Okay. Differentiate again with this. So x y2 plus y1 derivatives of x is 1. So that is equal to minus nb derivatives of sin is cos into bracket n into bracket log x minus log n into derivatives of this n. So n constant, log x is 1 upon x and 1 log n is 0. So this x will take on this side. So x square y2 plus x y1, that is equal to minus n square into bracket b cos n log x minus log n. Now if we observe this function is repeated here, so for that we will put y. So therefore x square y2 plus x y1 is equal to minus n square y from first equation. So x square y2 plus x y1 plus n square y is equal to 0. So if we take nth derivatives of this, so taking nth derivative, so x square y2 nth derivative plus x y1, addition means addition of derivatives, and plus n square constant, nth derivative of y is yn is equal to 0. Suppose this fourth equation. Now but here this product, this is the product. So by using Leibniz theorem, we will find the nth derivative of this x square y2. So by Leibniz rule, x square y2 n is equal to like this. So you know this uvn is equal to unv plus n into un minus 1 v1 plus n minus 1 upon 2 factorial un minus 2 v2 and so on dash. Last term is uvn. So by this rule we can write x square y2 n equal to, so un. Now here while choosing this, we will choose u continuous derivative and this is as v. So un yn plus 2 into v is x square plus n into yn plus 1. Put n is equal to n minus 1, so yn plus 1 into derivative of x square to x plus n minus 1 upon 2 factorial yn and 2. Next derivatives are zeros and so on. So x square y2 n is equal to, we get x square y n plus 2 plus 2nx y n plus 1 plus, now 2 factorial 2 gets cancelled, so n minus 1 and yn. So name this equation 5th. Similarly, we find x y1 nth derivatives, so this is u and this is v, so that is equal to yn plus 1 into x plus n into yn and derivative of x is 1, next derivatives are zeros, so x yn plus 1 plus n yn. Now putting in fourth equation, equation 4. So x square y2n is x square yn plus 2 plus 2nx yn plus 1 plus n minus 1 yn plus xy1 n the derivative, so xyn plus 1 plus yn and plus n square yn is equal to 0. Now yn plus 2 only one term, so x square yn plus 2, yn plus 1 two terms here, so we will combine 2n plus 1 x common yn plus 1. Yn terms, three terms are here, so n into n square minus n plus n and plus n square, this gets cancelled, so we get 2n square yn is equal to 0. That is the result, hence proved. So when example of this type, yn plus 2 etc. So you want to find cos y2. If the example contains maximum derivative yn plus 1, you find y1. So this is the application of standard formulae of nth derivatives and Leibniz rule to find nth derivatives results. So this is about the nth derivatives, very much detailed. I have taken nth derivatives. This is very much useful for JEE exams, all competitive exams, BEATS etc. Also for engineering, degree engineering exams, all the sides, civil, mechanical, electronics, electrical. Also, even though you will go in the IIT, there also you want to solve the examples by these methods. Okay, thank you.